Hey guys, happy Friday. I wanted to go over the homework from Thursday, just a few things quick before I started on the next lesson. And as of right now, when I'm making this video, not everybody has completed it. So the things I'm going to talk about maybe aren't necessarily mistakes that you made, but they're ones that I've seen on the assignments that I've looked at so far. Nothing major, but with the prime factorization, I just wanted to remind you about a couple things. First of all, anything that has a negative, so number 21, 22, 24, the very first thing that needs to happen is that you factor out -1. Okay, and then from there, you can continue with the rest of the factoring. So if I continue 21, the next thing would be times 2 times 7 times B times B times B. So I noticed two things. First was the -1. Not everybody was factoring that out. And then the other thing I noticed was that some of you were not putting the factors in order from least to greatest. And I probably could have clarified that a little bit better. I know I wrote up here somewhere, I think, numerical order, list the factors in numerical order. I probably should have said from least to greatest. It's not wrong, but typically you would see them listed least to greatest. So otherwise, from what I've seen so far, the prime factorization practice seemed fine. So if you have questions, I can hopefully answer them when I see you on Monday. So for today, you're going to be working on another topic that should be familiar to you, and that's GCF. But this will be the same as, with prime factorization. We'll do GCF with numbers and then also with monomials, or, there'll be some variables involved. So keep in mind with GCF, we're talking about greatest common factor, which would be the biggest number that, for example, 12 and 20, the GCF would be the biggest number that both 12 and 20 can divide by, right? Their greatest common factor. So generally, the ways that we do this are, sometimes you just know, right? Like you guys are pretty good at math facts, so you probably just know that the greatest thing 12 and 20 will divide by is 4. If you don't know, and for examples, when you don't know what they divide by, you have the list method, so you could just list all the factors, right? But it takes a while. And so hopefully with most of these, you won't need to do that. You can also use prime factorization to find GCF. You would have to write out the prime factorization of each number. So it's already done for you with 12 and 20, right? 12 would be 2 times 2 times 3. 20 would be 2 times 2 times 5. Then you could look for common prime factors. They both have a 2. They actually both have another set of 2, right? So there's like a 2 here and a 2 here. So I want to use one of those. A 2 here and a 2 here. So they each have 2 2s. Nothing else in common. So the GCF is 2 times 2, which is 4. I honestly don't use the prime factorization method for finding GCF very often because I think it's time consuming. There is a third way that we do GCF, and I'm not sure if the 5th grade teachers are teaching this method. Some are, some aren't, but we've also done something called a cake for GCF. And what that looks like is this. If my pen would work, you put the two numbers inside what we call a cake. Okay, and I'm having a lot of trouble with my pen. 12 and 20. There we go. And then I think of something, anything that 12 and 20 can divide by. You can do anything, 2 would work. The bigger, the better. So like I would maybe just go for 4, right? And then divide by that. So 12 divided by 4 is 3. 20 divided by 4 is 5. And 3 and 5 can't be divided. They share no more common factors. So there's my GCF. It's the number on the side. If there's 2 numbers on the side, you multiply them together. And I'll show you that again in another example. So one of the things you're doing is just finding GCF today, which, hopefully is a bit of a review from 5th grade. The bigger the numbers, the harder it can get. Now, this example, 30 and 24, this is another one where I think you probably know that the GCF is 6. You could do a factor tree, get the prime factorizations and prove it. You could do a cake to prove it. Divide these both by 6, and they share no other common factors, so I'm finished. So the GCF is, in fact, 6. You may also have to find GCF of 3 numbers, and you can do this the same way. So they have 54, 36, and 45. So for this, you're going to have to think now not just of something that 2 of those numbers have in common, but all of them. So you can see they've done the prime factorization method. They wrote out all the prime factors, and they found that all 3 numbers each have 3 in common. And they have it twice, actually, 3, 3, 3, and then 3 again. So I would multiply 3 times 3 to be 9. Honestly, for this one, I would probably try the cake. So I'll do that down here, 54, 36, and 45. So I think of something that they all divide by. Now, I know it's 9, and you'd probably come up with 9 just because of your math facts. So 54 divided by 9 is 6, 36 divided by 9 is 4, 45 divided by 9 is 5. And you can see that 6, 4, and 5 share no other common factors, so the GCF would be 9. So there'll be a couple of these for you to do today. And, if you know the GCF without having to do anything, that's great. Like, obviously number 1A, I know the GCF is 6, right? B, 16 and 60, I'm thinking maybe 4, right? But this would be a good time to just try this cake. Like if you think it might be 4, go ahead and do 4 and see what happens. 16 divided by 4 is 4. 60 divided by 4 is 15. So it is in fact 4 because they share no other common factors after that. So GCF of whole numbers should hopefully be familiar to you. But what will not be familiar to you is probably doing GCF with monomials. So I'd like to take a look at that next. So, in the lesson, I guess, that you watched yesterday, I introduced this idea of monomials. And so, a monomial is a number, a variable, or numbers and variables being multiplied together. So like these 2 things right here are monomials, right? And we can also find the GCF of monomials. So I have 16xy squared and 30xy. So to find the GCF, you need to factor these. Now, you'll notice the example here factors them out completely, right? So they wrote out the prime factorization. They even factored the variables, pulled apart the pieces there. That's up to you if you want to write all that out, or if parts of this you might be able to just kind of think about, right? So for example, the first thing I need to do is figure out what's the GCF of 16 and 30. The greatest number that 16 and 30 would both divide by. And that would be 2. So the GCF of the numeric part is 2. Now I have to go and look at the variables. I have x, y, y, x times y times y, and then I have x times y. So the only things that they have in common are one x, they each have an x, so I would put an x here. They each have a y. Now this one has an extra y, but in order for me to include it in the GCF, it has to be something that both of them share. So since they both have an x, I put an x in. They both have a y, I put a y in. And then that extra y is just not part of the GCF. So the GCF would be 2xy. Let's look at a couple other examples of this. Let me move this down a little bit. So take a look at maybe at 28. Okay, so I have 18 and 45 mn. So I'm looking for the GCF. So I start with the numbers. The greatest number that 18 and 45 can both divide by would be 9. They share no other factors. Since the 18 does not have any m's or any n's included with it, I would not include them as a common factor because they're not common. The 18 doesn't have those as factors. So the greatest common factor of those two would be just 9. The same thing's going to happen with number 29. So first I focus on the numbers, 24 and 32. And the greatest number that they can divide by, the GCF of 24 and 32, is 8. And then I'm not going to worry about the variable in this case because the 32 doesn't have any variables. So that's not going to be included in the GCF. It's not a common factor for them. Number 30, find the GCF of 12 and 40. And that would be 4. Okay, now this time there's an x with the first number and there's an x squared with the second number. So I do need to include an x down here, but only one of them. Because the one factor has 1x, this one has 2, but I'm only putting 1 in my GCF because it has to be the most that they have in common. Okay, so GCF of numbers and then GCF of monomials. Okay, and we'll try this today. I mean, you know, obviously this would be something that we probably need to talk about again in person. So do your best with this. Just think about what greatest common factor stands for. Right? And so you're going to kind of have to do it twice. Figure out the GCF of the numeric part. And I think in 36, that would be 21. And then also figure out the GCF of kind of the algebraic part, right? So I would want to have an X and a Y in my GCF here. I recognize that 21x squared has another X, but since the other term only has 1, I would only include it one time. So do your best with that. You know, and we'll talk about that. We'll follow up with it on Monday. The last thing that will be on there is factoring. And this is actually something that we've done before. So you'll be asked to factor expressions. And it ties in here because generally, well, not generally, but when you factor expressions, you're supposed to factor out the GCF. So it's been a little while since we did this. But remember that factoring an expression looks like this. I first figure out what's the GCF of those two terms. What's the biggest number that they could both divide by? And in this case, that would be 2. And then in the parentheses, I would have x plus 4, right? This is kind of like reverse of distributive property. So just make sure that it matches back up. 2 times x is 2x, 2 times 4 is 8. So the reason this is here is because when you factor these, you need to be factoring out the GCF. So for example, where's one? We could do this one. 15f and 18, they both would divide by 3. And in parentheses, that would leave me with 5f plus 6. And then again, just check it to make sure it matches back up. So today is all about GCF. Some of the practice will be, you know, things you've done before, just numbers. And then you'll have to try to figure out, you know, the GCF of some monomials. Do your best with that. Like I said, we can talk about that more on Monday. And then factoring expressions. So try the practice today. We'll see how it goes. I'll see you Monday so we can talk about it then if you have specific questions. Have a great weekend. I'll see you soon.